The average rate of change is the same thing as the slope between 2 points. It's the same thing as in a word problem, it'll generally be given as speed. So your rate and your speed are the same thing. Speed is actually the rate of change of your location over a period of time. I don't know if you've ever thought about it that way, but your speed is how fast your location changes with respect to time. If we're talking about straight lines, we just call it the slope. But if you're talking about some kind of a curve, and you pick out 2 points anywhere on the curve, then you're talking about the slope of the line connecting those the curves. The slope of the line, we usually just write as m. You can't actually get the slope of a curve, but you can get the slope of a line that goes through a curve in 2 specific points. Now, if I change the 2 points, that's going to move the line and the slope itself is going to change. You probably recall that the slope formula is written usually as y2 minus y1 over x2 minus x1. In the case of a nonlinear curve especially, they're more likely to write it as f of x2 minus f of x1 over x2 minus x1, which still means exactly the same thing. When you drive from point A to point B, your speed may not be exactly the same the whole time. Let's say at this point you're going 60 miles per hour, and then you hit some traffic, and here you're going 40 miles per hour. Then you hit a red light, and you actually stop to 0 miles per hour. So your speed changes over a period of time. But if you start at point A and you end at point B, if the distance between point A and point B is 30 miles, and it took you 1 hour, then your average speed, your average rate of change of your location was 30 miles divided by 1 hour is 30 miles per hour. Miles per hour, of course, means how far you go in 1 hour. That doesn't mean you were going 30 miles per hour the whole time. You could very easily have been going 60 miles per hour at some point and 40, and then stopped at some point, which is 0. But your average speed was 30 miles per hour. Let's say we've got a function f of x equals x squared minus 3x plus 4. And they want us to find the average rate of change from where x is 2 to x is 4. So the average rate of change is going to be f of x2 minus f of x1, just the difference between your y values, over x2 minus x1. Now it's a lot easier when you've got x values just you can plug in to go ahead and find what f of x1 is going to be and f of x2. F of x1, which is just f of 2, in this case, is going to be 2 squared minus 3 times 2 plus 4 is going to be 4 minus 6 plus 4 is 8 minus 6 is 2. F of x2 would be f of 4, which is going to be 4 squared minus 3 times 4 plus 4, 16 minus 12 plus 4 is 4 plus 4 is 8. So coming back to the formula, f of x2 would be 8 minus f of x1 is 2 divided by x2 is 4 minus x1 is 2. This is 6 over 2, which is 3. Now, they may at times give you variables to plug in instead of number values for x. So f of x2 minus f of x1 over x2 minus x1. Well, we can still simplify this. F of x1 is going to be f of a. And since there's no numbers to plug in, it's just going to become a squared minus 3a plus 4. F of x2 is f of a plus h. Now, because I'm plugging in an a plus h, this is going to require some simplifying. So I've got a plus h squared minus 3 times a plus h plus 4. When I square this out, it's going to become a squared plus 2ah plus h squared. Remember that this is a plus h times a plus h foiled out, minus 3a minus 3h plus 4. And I don't have any like terms here I can combine. So this whole thing is f of x2. All right, a squared plus 2ah plus h squared minus 3a minus 3h plus 4. That whole thing is f of x2 minus f of x1, which was up here. So minus parentheses, because it's the whole thing being subtracted, a squared minus 3a plus 4 all over f of x2 is a plus h minus f minus x1 is a. Now, when I carry this negative through, I get a squared plus 2h plus h squared minus 3a minus 3h plus 4. Carrying the negative through is going to give me a minus a squared, a plus 3a, and a minus 4. Make sure I change that. This was positive, negative, positive. Now it's negative, positive, negative. Okay, good to go. With the whole thing, these are going to cancel. So this is now just over a plane h. So we've got some more things that'll cancel here. The a squared and the minus a squared are gone. A negative 3a and a positive 3a are gone. A plus 4 and a minus 4 are gone. So this is now trimmed down to 2ah plus h squared minus 3h all over h. H is a common factor in the top. So if I factor out an h, that would be times 2a plus an h minus 3. Double check, h times 2a is 2ah, yes. H times h is h squared, yes. H times a negative 3 is a negative 3h, yes. That is over h. These cancel, and that whole big mess has now thinned down to just a 2a plus h minus 3. Now, not to get you too excited, but this is actually nothing but the slope formula, right? This is just y2 minus y1 over x2 minus x1, but written in such a way that you can apply it to 2 points on any curve, not just necessarily a straight line. On a straight line, the slope never changes. On a curve between 2 points, it's constantly changing. This slope formula is the basis of calculus. Let that settle in for a second. This is the basis of calculus. What they do in calculus is they take 2 points along a curve and they let the x value at one of them be x, and the x value at the other one be x plus h, where h is the distance between the x values. They squeeze those points together more and more and more until h becomes 0. The problem, of course, is that when you've got something over h, like you do here, or you do back here, because the a's are always going to cancel out on the bottom here, so you end up with just an h in the bottom. They simplify that as much as possible to get the h to cancel out of the bottom. And then they take the limit as h approaches 0, so that the 2 points become 1 point. Then it becomes the slope of not a secant line that goes through 2 separate points, but the tangent line, a line at a slope line that goes through just 1 point. The limit of this as h approaches 0 is the slope of the tangent line, which is the same thing as the derivative for the function. So now you're doing calculus and you didn't know it. Smarter than you thought, huh? So I hope you enjoyed that little adventure, and we will talk to you later.